In this video, we'll discuss about what is meant by electronic configuration. In previous video, we did discuss about what is atomic number and what is mass number. So here we have electronic configuration. So what is basically electronic configuration? In the previous video, we stated that the number of electrons are there. They revolve around the nucleus in a designated spaces. Now all of them doesn't stay together. So they have been distributed in particular shell or level. So this arrangement or distribution of the electrons, this arrangement or the distribution of electrons in various shells or orbits or energy level are called as electronic configuration. So here it's basically the arrangement or the distribution of electrons in various shells or orbit that is called as your electronic configuration. Now the electrons are there, they possess a certain fixed energy, and as they move away, the energy of that level goes on increasing. Okay. Now generally the distribution of electron is based on Bohr-Bury rule. It's based on Bohr-Bury rule, which is 2n square rule. So this rule governs the distribution of electron in various shells or orbit. Okay. So the very first rule says that the maximum number of electrons which can be filled in a particular orbit or a shell, the maximum number of electrons which can be filled, the maximum number of electrons which can be filled or accommodated in a particular shell is been given by general formula 2n square. It's given by general formula 2n square, where this value of n indicates the number of shell or the number of energy level like 1, 2, 3. That way we can take it. Okay. So suppose if I put the value of n is equal to 1, so it is 2n square. So 2 into 1 square, okay, that becomes 2. So in the first shell, I can fill maximum of electron, that is 2 electron. Okay. Thus, if I take n is equal to 2, so it is 2 into 2 square, that is 2 into 2 square is 4. So 4 into 2, that is 8 will come. Okay. So maximum number of electron which can be filled in the second shell, that is 8. Then if I put n is equal to 3, if I put n is equal to 3, I get 2 into 3 square. So 2 into 3 square is 9. So 2 into 9, that is 18. So third shell, I can fill up the maximum number of electron, that is your 18. And suppose if I take n is equal to 4, so 2 into 4 square. Now 2 into 4 square is 16. So 2 into 16, that will become 32. So I can fill up maximum number of electron in fourth shell, that is 32. Now generally these shells have been designated with some alphabet. They have been designated with some alphabetical number, alphabet we can say. So the first shell has been given as an K shell, second has been given as an L shell, third is given as an M shell, and fourth is given as N shell. So for a simplicity, if you would like to remember, I can say K for Kali, L for Lali, M for Mali, and N for Nali. Now generally see X, Y, Z, A, B, C, D, these have been given by wherever we take any variable, these are the common variables taken. So this is something which starts with the K, which normally people do not take it, more or less, except we take a constant as in K. So this is my assumption why he chose K as a first. So you can remember that particular K as in Kali, Lali, Mali, Nali, and so on. So we can have these 4 shells are there. And as we are studying only electronic configuration to 20, this is more than sufficient we need to know. Okay. Now, the next point which we have here, the outermost shell of an atom. Please understand this particular point very well. The outermost shell. So we have outermost shell of an atom cannot have more than 8 electrons. This is very important condition. The outermost shell of an atom cannot have more than 8 electrons, even though it has got a capacity to hold more than 8 electrons, even if it has got capacity to fill up more than 8 electrons. Hence, the penultimate shell, penultimate shell means the shell which is second last from the last, we can say, cannot have more than 8 electrons in its valence shell, cannot have more than 8 electrons in that shell. Now, how you can work out this particular thing? So, we have, let us take a simple example here, potassium, whose atomic number is 19. So electronic configuration, if I take the above values, it is 2, 8, 9. Because this is total 19 electron I can fill. In first shell I can fill 2 electron, second I can fill 8 electron, and third I can fill as 18 electron. But I am having 9 electrons, so I put it 9 there. But this is wrong. But this is wrong as per above. So we modify this particular thing. Potassium we write 19 to 2. So this becomes your penultimate shell. We can have this particular 2, 8, 8, 1. So I redistribute the electrons in terms of this way. This is K shell. This is L shell. So here I have, see, the outermost shell of an atom cannot have more than 8 electrons. Here I filled up 9 electrons. So one has to be subtracted from there, will get promoted to the next energy level. So I'll get K, L, M, and this becomes your M, the fourth shell, which has got 8 electrons. So here, this becomes your penultimate shell. We cannot have more than 8 electrons there. Okay. Then the next rule says that the new shell begin as soon as the outermost shell attains 8 electrons. This is what we have studied here. Outermost shell has got 8 electrons. The next electron will start moving to the next level, we can say. So this is about your distribution of electron, how it has been made based on Bohr-Bury rule. Bohr-Bury rule. So please do remember this particular 2n square rule as a formula, which will help us, or which enables us to find out how many electrons can be filled in a particular shell. Okay. Thank you for watching.